Well, I've got a little bit of a mystery here. I was working on the 5-volt power supply. This would be the little power supply that would take the LIPO 12 volts down to 5 volts. And I know I'm going to need a couple of them anyway. And here they are. These are the power supplies that I showed you before. They're the DC to DC converters. But what I've done is just couple two of them together with some standoffs. And let me back that up just a little bit. I should have done this before I hooked it up, but I always go the opposite direction. Let's see. What we've got here, we've got input on this side, and then we have output on this side. And I've got one input, and as what you see is you see that I've got 12 volts coming down, going to the input side of this. I know my big fat hands are in the way, but on the input side of this buck converter, this DC to DC buck converter, down converter. And what I did is I tied wires up from one of the DC to DC supplies to the next. Just tied them up just so that I would have one common input coming in, going to both of them, here and here. And then I tied the two units physically together with these standoffs. And then this will be the bottom of it, which will be screwed onto the plate of the robot. So I'll have two 5-volt supplies there. This is the output, the top one, the top output, and then the bottom output. Okay, so and I've tweaked them via the adjustment knob. They're both outputting around 5 volts. But here's the mystery. I'm going to set that there precariously. The mystery is that I only have one output, going to a resistor, resistive load. The other output is just dangling free. And this is the resistor, and trust me, this resistor is well, it's very hot right now, but it's 10 ohms. It's a 10 ohm resistor. Read it right off. It's 5 watts 10R. So it is a 10 ohm resistor, one of those big ceramic block types, you know. So 5 volts divided by 10 ohms is half an amp, right? I mean, that's what I should be getting. And that's coming out of the top converter, the top power supply of this little group here. The bottom one is just going to a couple of leads. I'm just measuring the output. I don't have it going to any type of load at all. We move up to the outputs, or whether I'm measuring outputs rather. The multimeter on the left is the one that's tied to nothing. That's the DC to DC converter that just goes nowhere. It's just dangling. It just goes straight into the multimeter there. It's 5.07. That's where I set it. Now the one on the right is that's the output of the one that's going to the resistive load, the 10 ohm load. Okay, so we've established that we have two 5-volt outputs coming from the DC supplies. One of them has a 10 ohm load and one of them has no load. That's fine. I'm just testing them. Then here's the supply it's coming from. This is a nice little precision supply, by the way. I'm sorry about that. This is a nice little precision supply, by the way. It's a Handtech. This is not your top tier. Let me tell you, I don't have that big of a budget, but it works nice. Well, I did have to take it apart and fix it when I first got it. When I first got it, in about 3 days, the display blew, or wouldn't come on. The display would not come on, and so I took it all apart and traced it to a 7805 little 5-volt regulator in the back of it. It was a surface mount type, one of those really tiny packages, 7805. So what I did is just put in a full-size package there and really blobbed on the solder to give it some extra heat sinking, and voila, that fixed it. So it's worked fine ever since. So I call it a good supply. It did break 3 days after I got it, but anyway, I fixed it, and it's been really good. Well, what we can see is we see 12 volts is the output voltage, because that's approximately what the LiPo was going to put out. And then in the bottom number is the current, and it's putting out 250 milliamperes. Well, that's putting out 250 milliamperes into that 10 ohm load. So, and this is a current limited. It's a pretty good. See, if I turn off the output, see this one here, I'm limited to 1 amp. I don't want this to go over 1 amp. That's fine, and I don't want it to go over 12 volts. That's fine. Those are my settings. So I turn on the output, and it doesn't current limit, because you see there's your voltage is 12 volts, but the current is not CC, is not lit up, so it's not current limiting. That's the output. So it's 250 milliamperes coming out there. So that's my current little mystery here I've got going. Figure out why is that doing that. Am I limiting on the board itself somehow? On the little DC to DC board? Because when I have these, or is there something going on with my coupling where I physically coupled them together with those metal standoffs? Maybe I've got some plastic standoffs coming in. So maybe I have to wait and get use the plastic standoffs. Maybe I'm shorting like ground to ground between the two or something, and I've got I'm leaking somewhere. But nothing's getting hot on I'm touching them now off screen, and neither one of them are getting even anywhere close to warm or anything. And one individually I've tested up to 2 amps, and it started getting a little bit hot up to 2 amps, but I tested up to 2 amps for a while, and it was fine. So I know they can put it out. So maybe I with those metal standoffs, I've done something. I'll have to do some probing around to see if I'm shorting. The only place it would short would be the ground of one of them to the ground of the other. On the output side of them. Now, what would that do? I don't know if it's just the ground. I know that if you take two DC to DC converters and you put the outputs together, the pluses and the grounds together, and they're not balanced, then you have to put in balancing resistors so that the current, so you don't, if one of them goes over just a little bit, you can start drawing lots of current in from one to the other. So you have to be careful with that. Although with linear regulators, 7805s, I put those in a string of 5 one time, and I made all the inputs common and all the outputs common, and it worked just dandy. And I had a 5 amp power supply, and it lasted for 2 years. Let's see, wasteful in energy, but it worked and it was cheap. But anyway, I'm trying to figure out why this is 250 milliamperes, and it could be something I did. It could be it could be some current limiting on the device itself. It could be the coupling that I put these metal. That's really a neat power supply. I like it. These metal standoffs that I have going between them are very close to the inputs and very close to the outputs. It could be that I have a short there, so I gotta do some probing, I guess. But I wanted to share that with you, where I was at with getting the power supply put in, because I wanted to double stack those just for room on board, and I might even triple stack one, or have 2 double stacks, depending on how much current I need. But hopefully I can just put the outputs of this to the terminal blocks, these guys, terminal blocks, and then just pull off of that, and hopefully not need that much current to keep this thing going. And I will let you know when I find out what's going on. Well, I'm looking into the mystery of where it only supplied half the amperage to those DC to DC power supplies, the two that have physically coupled together. And I got kind of off on another thing. There's the 2 outputs, one, right at 5 volts each. That's fine. I still have I put a load resistor on the second one. It's not just dangling now. I put a load resistor of, it's 8.2 ohms actually. So anyway, so it roughly doubled. The one is 10 ohms and one's 8.2 ohms. So at 12 volts input, 5 volts output for each one. One has 8.2 ohms on it, one has 10 ohms. Should be getting more than that, but here's where I found something very strange. Excuse the camera movement there. I'm not doing a very good job of that. And I'm cleaning up. This is Labor Day weekend, so I'm cleaning up my desk so you won't see all these wires and everything everywhere. It'll be a lot cleaner and easier to look at things I'm pointing out. If I do this, if I it's at 12 volts right now, right? And we're getting the parallel current of the 8.2 ohm in parallel with 10 ohms. But anyway, we're getting roughly half of what we ought to be getting. If I do this, let me turn off the outputs right now. I've just limited to 2 amps. That's why the 2 amps is there. It's 12 volts. And if I come down, if I bring the voltage, select the voltage, bring it down to 7 volts, and then let it settle. Okay, there now when I turn this on, it's going to be at 7 volts will be the input, and 5 volts should still be the output. Now look at it. Now we're at 990 milliamperes, almost an amp. Now we're where we should be. I brought so basically the input voltage going to the DC to DC converters, I brought down to 7 volts from 12 volts, and we increased our current output to where it should be. It's not current limiting, so I think if I creep over here, we can see that the 2 outputs are still right at 5 volts. That's great. So I think the DC to DC converters are current limiting. Well, when I was doing that and turning off the output on and off, I thought I saw one of the meters jump to 6 volts. And that scared me, because I don't want to turn this thing on. You know, LIPO battery is connected to a switch. The switch is connected to the inputs of these 5-volt power supplies, little DC-DC converters. And you turn that on, and I suddenly am putting 6 volts to, you know, an Arduino or something that's supposed to take 5 volts. I know the Arduino's got built on a little regulator, but something that doesn't have that, it takes that 6 volts, and I end up ruining something. So let's do this. We're going to, first of all, I'm going to put that back up to 12 volts. And you can just do that. You can do it live. See how the current's going down? I think there's some internal current limiting on those DC to DC converters, is what I think. I need to read a little bit more about them. So what I'll do is look up, I've got, oh, you can't see that at all, can you? I've got that that chip there. I've got it. Ouch. I've got it. I know what that chip is, so I can look that up and see if there's what's going on there with that. Because these, by itself, is performing fine. I haven't done any of the checks on the coupling, whether one is shorted to the other or not. I haven't done any of that. I need to do that. But I kind of got off on the power supply here. When I saw that go to 6 volts, when I turned on the input to that, it worried me that it would jump over. Well, so let's do this. I'm sorry, let me swing back. Let's do this. Now that we're at 12 volts, let's turn that off. The output is off. The output's off. And we have 0 on the meters. 0 voltage output. And let's set this up As you can see, I've done it, but I wanted to show you what I've done. Let's set this up for a single. It's going to capture it as it rises and gets triggered when I turn that on, and we should see the waveform come up. Is that camera at a bad angle or what? We should see the waveform come up, and I got to get a better tripod. That's what I'll do. And so let me hit the output. Okay, the output just triggered. As you see, there's the rising edge of the power supply. Let me zoom in on that just a little bit. Right there, as you can see, and that's 2 volts per division. And for some reason, my graticules are not glowing. My graticule light should be brighter than that. But anyway, trust me, it's 2 volts per division, and you can see the voltage. I need a long pointer, don't I? The voltage here is 5.44 volts. So I don't, as maximum. So I don't quite understand that. Because the meters are reading 5 volts at the circuit. I can only think maybe that's some, I don't know what that is actually. But I don't see the overshoot. That's what I was more concerned about, was the overshoot of going up past 6 volts or something. And I do see that at the circuit, at the load, it does stay 5 volts. And I'm going through a couple of thin DuPont wires to my scope, because I didn't want to hook the scope up directly to the resistors, because there's such an elevated temperature right now, and I don't want to put that kind of stress on the scope leads itself. Scope probes, or the scope probe. So let's see, I'll just leave that like that. And let's do that one more time. We'll turn it off. Output is off. Go back into single trigger. And then, boom, we're going to 600 milliamperes, which ought to be about an amp, as we saw when I dropped it to 7 volts. Interesting, but it's ramping up okay. I mean, we're not overshooting, so I feel confident that I can turn a switch on, a hard switch, an actual hard switch, turn that on, and supply power to these things, and they're not going to blow whatever 5 volt circuit I've got them attached to. Let's try one more thing. Let me turn that back down. I won't show you, I'll just do it. I'll turn it back down to 7 volts. Now we're getting an amp output, which is about where we ought to be. Actually, ought to be a little more than that, and because that's a 2 volt differential between the input and output. See, that's a 2 volt differential between the input of the DC power supplies, the two that are coupled together, and the output. And why would that allow this? Maybe this is just something so obvious and I'm just being stupid, because that's never happened before. So here we go with now we're at 7 volts with almost an amp output, and I'm going to turn it off, and then we're going to turn it back on. A little different with that 1 amp output. We can see it climbs up to, well, according to the scope, 5.36 volts. But my meters are saying 4.95 and 5.0, so I'm going to have to go with the meters as on the output. But we can see that the ramp up is okay. I don't see any big overshoot, no big spikes or anything. And that's at 7 volts, and the other one was at 12 volts. So anyway, it's a little bit of a, it's still a mystery as to why at 12 volts I'm only getting half the current output. And the only thing I can think of is there is some sort of limiting circuit or limiting capability on the little power supply itself. And I'm going to look up the data sheet of that chip, and I'll check that out. Maybe, and I don't have a schematic of that though. Well, there is a schematic that's close to it on the web. I was able to find a schematic that was pretty close to it, but it didn't have the adjustable part. It was, if you're going to set it as a 5 volt output only, I found a schematic, but I couldn't find the adjustable one. But that shouldn't be too hard to figure out. But I'll see if it's got something like that. And anyway, I wanted to show you that, and I thought that was kind of interesting. I love playing with power supplies. They're kind of the forgotten son of the electronics, because people don't think of them as part of the electronics. I worked for a power supply company for about 6 months, actually, and a long time ago, and companies would come to us to design a power supply, and they would design it, and then it was the last thing they thought of. Everything else was designed, and they said, okay, now the power supply's got to fit in this position, and it was like a Rubik's Cube in order to get, you had to position it in there such that it was, well, you couldn't hardly fit it in there. It would just jut out in all different directions, and the box would go in. But anyway, we built them and supplied power supplies that way. But I always thought they were fun. And now I need to do some more testing here with the power supplies, and then hopefully get those mounted.